Okay, let's go ahead and get started. Hello and welcome everyone. Thank you for joining us today for our Ask Me Anything session with Arno Kandel on the future of automatic machine learning and H2O driverless AI. My name is Patrick Moran. I'm on the marketing team here at H2O.ai, and I'd love to start off by introducing our speaker. Arno Kandel is the Chief Technology Officer at H2O.ai. He is the main committer of H2O3 and driverless AI and has been designing and implementing high-performance machine learning algorithms since 2012. Previously, he spent a decade in supercomputing at ETH and SLAC and collaborated with CERN on next-generation particle accelerators. Arno holds a PhD and master's summa cum laude in physics from ETH Zurich, Switzerland. He was named the 2014 Big Data All-Star by Fortune magazine and featured by ETH Globe in 2015. You can follow him on Twitter at Arno Kandel. Now, before I hand it over to Arno, I'd like to go over the following housekeeping items. We'll be using Slido.com to display your questions throughout the Ask Me Anything session. Please go to Slido.com and enter the event code AskArno. That's one word, AskArno. Once again, Ask Arno, AskArno. We'll be displaying all of your questions on Slido, and you are encouraged to upvote the questions you'd like to hear answered first. The most popular questions will rise to the top of the display board, as you can see on the screen right now. So once again, Slido.com, Ask Arno. And the session is being recorded, and we will provide you with a link to the copy of the session recording after the presentation is over. Now, without further ado, I'd like to hand it over to Arno.
Thanks, Patrick. Thanks, everyone, for joining today. I'm very blessed to be speaking for this great team at H2O. We have a tremendous team of people, not just the grandmasters that are so popular, but also the software engineers. The entire team is really working together. The sales, the business units, they're all coming together. And the products that we've made in the past have been really novel and innovative. And driverless AI is continuing this tradition where it's something new that you haven't seen before. And in this demonstration today, if I get to do that, that would be my privilege. But I really would love to answer some of the questions that you have. And also the times are, of course, challenging these days. What can we do about that? What's the role of data scientists? What is machine learning going to do? And so on. And driverless AI is addressing some of those issues already in its latest incarnations. And I will show you what's new in driverless AI to start with. And I'll give a very quick introduction to driverless AI so that everybody's on the same page. So let me share my slides here. As you know, driverless AI platform for building machine learning models. That's the gist of it. But the machine learning models aren't just any machine learning models. They're actually rich pipelines full of feature engineering. And the feature engineering is the magic sauce, if you want, inside this platform, where it takes the data and changes the shape of it slightly so that the juice can be extracted in a better way. Like the signal to noise ratio is very high. We can get the best models in the world, and not just for tabular data set, but also for text or time series or now images. And the whole thing is basically meant to help data scientists, right, to get to production faster. So what does it mean, production? It means you get a model out at the end that's usable, that's good, that's validated, that's documented, that has a production pipeline that is ready for production. And the production pipeline has to run in Java, not in Python necessarily, has to run maybe in C++ somewhere. And all of this is automatically generated by the platform. And it can train fast on GPUs and so on. So it's well designed to be the best friend of a data scientist. And in the last 2 or 3 years, we've been coming up with a lot of features thanks to our customer support and all of us. We've been looking at this whole thing as like visionaries, right? We wanted to make sure that the product can do stuff that nobody would think was possible 2 or 3 years ago. And now it's reality, and it's just one more milestone along this roadmap. So we started with the Grandmaster recipes, and then it became GPUs, and then it became time series, it became machine learning interpretability, automatic documentation, automatic visualization, connectors to all the clouds and all the data sources. It became suddenly deployable on Java and C++. You know, they take the whole pipeline to production as it is with all the feature engineering. This was a miracle almost. And then we also shipped it to all the clouds on-prem anywhere. So it's really just a software package. We don't care where it runs. And also it has Python and R client APIs. And now last year we introduced the bring your own recipe, which means you can make your own custom recipes inside of driverless. You can make your own algorithm data, your own feature engineering, your own scorers, KPIs, and your own data pre-processing. And all of that is Python code. So if you're a developer of this, you can really customize anything. You can add your own PyTorch transformers if you want. You can add anything. You can download, join, group by, augment. You know, you can make your own marketing campaign cost scorers. What you can think of in Python land, you can do in driverless. That's the rule, and that's pretty amazing. And I would like to say that in the next generation of the version of 2.0, which will also be long-term support, just like 1.8 is right now, we'll have another milestone, which is multi-node, multi-tenancy, multi-user, you know, model import, export, and all that. So, and then once you have the models in the model deployment platform, you can manage them. You can say, hey, is this model better than the previous model? A/B testing or challenger model. Models that are drifting, automatically retrained or alert raised, or different kinds of alerts. You can even do custom recipes for those alerts. So we want to empower the data scientists to infiltrate the whole organization back to data improvement. So we'll tell the data scientists through driverless AI what to improve in the data. And then once they know what to improve on the data, they get better data from the downstream engineering and from the upstream data engineering, and then can make insights with driverless and then pass on those insights downstream to the business units that consume those applications, right? And we want to make sure that the data scientists are not just given a data set and then they play with it, but they actually can impact the business outcome by going both to the business side, but also to the data engineering side to like ask for improved data. And also the next generation platform will have a custom problem type. So you will have image segmentation, for example, multitask, multi-target learning. Whatever you want to do, you can do in the driverless platform. That's our vision for the future. So this is just a short list of the new features we introduced in our current generally available offering of 1.8, which is the custom recipes, the project workspaces, and then a bunch of smaller, simpler models, and then also more diagnostics, like more validation scores and so on. And I'll show some of those things later. But as you can imagine, we connect to pretty much any data source in the cloud, on-prem, Hadoop, you know, Oracle databases, whatever, Snowflake, you mention it. You name it, we have it. Custom data recipes allow you to quickly prototype your pipelines. You can make up new features or compute aggregations and so on, convert transactional to IID data, whatever you want to do as a recipe, as a Python script. You can look at the data quickly. In one click, you get the visualization of the relevant information that matters. The feature engineering is our strength. If you want, we make features that are very difficult to engineer and hard to come up with if you're just starting out, let's say, and it can have a lot of information in there, such as interactions between numeric and categorical columns and so on. And then there is a evolution of the pipeline where not just the features are selected and the models are selected, but all the parameters are tuned of the feature engineering and of the pipeline parts that are models. So we have millions and millions of parameters that are being tuned and refined, and in the end the strongest will survive, and that will be the final production pipeline. And we will make sure that the numbers that we report are valid on the future data sets, right, if they're from the same distribution. So holdout scores, validation scores that are trustworthy. And of course, there is a lot of statistics going on, deep learning, not only deep learning, also gradient boosting, all kinds of techniques to reduce the dimensionality, to do aggregations between, you know, of certain statistics across groups, For example, for every city, every zip code, you get some mean number, but only out of fold. So it's all like a fair estimate of the behavior of populations and so on. And all that is done automatically for you. And if you're an expert, you can control it all with these expert settings. There's several pages of these where you can control everything. For time series, there is, of course, a causality that you have to be worried about. So you can't know about COVID until it's happened, have the knowledge about COVID in last November or so. So this is exactly why these validation splits are so, especially for time series. But sometimes you also have to do validation splits for non-time series problems that are specific, like with a fold column, only split by city or something, only shuffle the data. And driverless can help with that as well. For the natural language processing, there's many different approaches. With the custom recipes, you can do anything you want, but in 1.8, you have TensorFlow, convolutional, and recurrent models, in addition to the linear models and the text features that are statistical. But in the version 1.9, you'll have BERT models, PyTorch BERT models, which can improve the accuracy even further. And machine learning interpretability has been a key strength of driverless AI for the last few years. And we have further enriched it with disparate impact analysis, where you can see how fair a model is across different pieces of the population and different metrics. So you can see, is it like, you know, singling out somebody or some specific feature of the data set. It doesn't have to be just people. It can also be just in general, is your model somehow biased? You want to know that. And then there is a stress testing capability, where it's like a what if analysis, a sensitivity analysis, where you can say, if everybody was a little bit older in this zip code, what would happen? Or globally, or if everybody had more money, what would I have done? So it's basically an exploration in the meaning of the model's behavior. And there has been a new project workspace where you can compare models that are organized by you. So you can say, here is a data set, and here are my models for this data set. And then you can sort them by, let's say, validation score or by the time to train them or so on and so on. And you can then look at them visually and see models and so on. So there's a way to quickly compartmentalize your experiments. And this whole block will then later be exportable in 1.9, so that you can share this whole experiment project page, so to speak, with other people. So you can share entire experiments based on their project belonging. And new in 1.8, we also added a scores tab, which means in the GUI, you can see the statistics about the different models. So for example, the leaderboard, you can see that BERT models do better than statistical models or better than TensorFlow models in a glimpse, basically. You quickly see a leaderboard, what's happening, feature evolution from the model tuning part, where you can quickly see what's happening right now. You can also see the final pipeline, how is it behaving, which model is contributing how much to the final pipeline, how many cross-validation folds did it have, and if it had cross-validation folds, then what was the score in each of these folds? The out-of-fold predictions, how did they do on each fold? Is it stable across folds, or is there some noise in the data? And it helps you to see all the metrics. And as I mentioned earlier, we have Python and R clients where you can remote control driverless. So if you don't like the GUI, you can do everything from the command line or from the programming APIs, and everything is automatically generated. So you will always have the latest version of all these APIs for every version that we ship. And then when the model is done, you can score the models in either Java or R or Python or C++, which is what R and Python are using underneath. Or you can, of course, call the GUI and say, please score me this data set. The GUI can always score using the Python version. So there's two different Python versions. One is using the C++ low latency scoring path, and one is using the full pickled state that was trained during training time. So there's a bunch of ways to score, and it's quite fascinating to see how people are using those in production. So if, for example, you can train a model with GPUs, XGBoost, and TensorFlow, then you get a Java representation of the whole pipeline. You stick that into Spark and you score on terabytes in parallel at once, and you have no loss of accuracy. And this is what such a pipeline looks like. So you can see all the pieces in the pipeline from the left side, the original features coming in, getting transformed into datetime features or lags, and then aggregations between the lags, and then back into LightGBM to make a prediction. And a decision tree, for example, would be visualized like this. So you can actually look at the split decisions and see what the outcome is for each case. So there's a lot of transparency in our pipelines. Everything is stored as a protobuf. So there's a binary representation of these states, and you can inspect them and you see what you get. This is absolutely the full pipeline that we are visualizing, which is being productionized in the end. So no shortcuts. And every piece that we ship out of the box has a deployment version of it for Java and C++. And if it's not yet in Java, then it will be soon, because it can call C++. Like TensorFlow and PyTorch, for example, they work in C++, but once you have Java, you can make it a JNI call. And we're working on giving that to you out of the box as well. So the rounding off of all these extra cool AI features in the production pipeline is happening right now. And this is how it looks like in Python. When you load this protobuf state and you say score, you immediately get the response in Python, and there is no dependency on any pip installs of TensorFlow or whatever. It's all built into that protobuf state, and it's all it's serialized into a blob of bytes, so you don't need to worry about any dependencies. And if you don't like the Mojo size, sometimes they can be 3 GB or bigger for a normal 100 MB data set, because this is a grandmaster level Kaggle winning pipeline. In this case, this is 10th place out of the 2000 or so in Kaggle. And this is out of the box with one push of a button, right? But sometimes you say, I don't want 15 models, I don't want 700 features, it's too complicated. You have a button there new that says reduce the size of the Mojo. When you click it, the whole thing becomes 16 megabytes, and it's faster to train, faster to score. The accuracy is still pretty good. So maybe you can start with that to see how it behaves. But as I mentioned, there is just some presets that we apply. You can also change those presets and make your own custom size of the overall pipeline. You can always reduce it to not be an ensemble, or not have more than so many features, or not have higher order interactions and so on in the feature engineering. So everything is basically controllable by you. And then once you're done with the whole modeling, you can deploy it to Amazon or to the REST server that's built in, or all these other places you can go with Java and C++ that I mentioned before. These are just 2 demo things that we build into the product. And then the open source recipes, the custom recipes, you can do whatever you can do in Python. That's very powerful, right? Anything that you can imagine, your own target encoding, your own voice to speech, to whatever, voice to text, to featureization, your own scorers based on some quantile of the population, or your own scorer that's fair across different adversely impacted populations, or your own data preparation where you take 3 data sets and join them and split them exactly the right way, and then you return all 5 at once in one script. All this is doable today, and you can make your custom models. You can bring CatBoost, for example. You can bring MXNet. You can bring, you write your own algo, you bring it in. That's how easy it is. And we have over 140 now. It's I think 150 open recipes that you can see how it's done, and you can customize them, or do whatever you want. It stays your IP, and you can have your insights be part of the platform. And this is just how it looks like. You can bring all the H2O open source models, for example, into the platform. You can bring, there's extra trees from sklearn and so on. And then in the end, you can just compare them, and you see that BERT has a lower log loss, in this case 0.38, versus the built-in ones get only to 0.5. If you enable TensorFlow, or if you don't enable TensorFlow, then you only get a 0.6 log loss. So you can see it almost is quite a milestone here, that you can get to that lower a loss for the sentiment analysis. This is a bunch of tweets, and you want to predict the sentiment. It's a 3-class problem, so positive or negative or neutral. And you can imagine that having the knowledge of the language, like the BERT model does, it means a lot, right? If you understand what someone is saying by looking both forward and backward in the sentence using these smart neural nets, then of course it's better than just counting the number of ands and ors and hellos and so on in a sentence. So that's what it is. And the same is true for time series. If you have a Prophet, Facebook Prophet model or ARIMA model that you like, you can bring it in as a recipe, and then you'll have a different score than what we have out of the box. And sometimes it's better, sometimes it's worse, but the interpretability might suffer a little bit because you only have your black box that now makes predictions, and that's all you will see in the listing of the feature importances. Whereas in our case, you would have at least still this lag of this feature mattered this much to our model, right? So once you make your black box models, you need to think about how you can give them the variable importance back. And if you can do that, then we will show your variable importance. So if you make your own random forest, then we will show that, of course. So that's the point here, is that whatever you do, you need to still be in charge of it. And that's why we try to do as much as we can out of the box. But sometimes, like you said, there is a trade-off. Like I said, sorry, there's a trade-off between interpretability and predictive accuracy. And you can see it here in the case of Prophet. In the end, it's not better, but it just is one black box Oracle model versus a bunch of lags going into XGBoost, for example. And that's the last thing that I want to mention from the introduction slide section. That's the automatic documentation. So you get a 20 or 30 page Word document for every experiment, filled with distribution plots and leaderboards and parameters that were used, and it shows you a lot about what's going on. So I would say this is very useful, especially for regulated industries or people who want to keep track of what happened. And then we can dive into the sneak preview into what's coming next. But I'll keep that for a minute, and I'll address maybe one question in the meantime. So let me look at the Slido page. Yes, what's the value of data scientists and machine learning specialists these days? I would say even more than ever, right? Imagine there was a time when there were no computers. Everybody said, oh, wow, these robots are going to take over my job. Are they going to, replace people who type in stuff or what, or who make decisions? Yeah, of course they will, but you will still be working with them. Everybody now has a laptop or an iPhone in their face all day long, right? So you're going to work with those computers, and if you don't, someone else will. There is definitely a need to do that in our competitive world, and you will benefit from these tools or platforms, whatever you call them, or you won't. And if you're a good data scientist in 2030 and you don't use these tools, then you better have something else up your sleeve, right? There is no way that the people that want to be competitive don't use these tools. So that's another way of seeing it. So they will add value in many places. As I mentioned, you want to be involved with the data preparation step. So for example, in driverless, when you have an experiment, in the next version will tell you that in Minnesota, there wasn't enough information to make conclusive predictions. So get better data for Minnesota. That's all possible by the model itself, to figure out where it's strong and where it's weak. And that can be something you can bring back to your data engineering team and say, why don't we have good data in Minnesota, right? Or you can bring it to your management team in the business side and say, that's the reason we don't make money, right? And then they will say, well, maybe we shouldn't do business there or something. So these are all like ideas, roughly speaking, where you as a data scientist can be more involved in the overall business. And you want to be entrenched as a business strategist. You don't want to just be given a data set and then you play with it for 5 weeks and then you say, oh, I have a good AUC. These days are over, I would say. It's more important to know what it means and to know what it exactly does right now. And if that assumption is no longer true, then you should change the overall pipeline and the place where it fits. And tools like ours will help you figure out what piece of the signal is actually strong and what piece of the signal is weak and what's driving what. So we're getting more into the causal place, let's say, no longer just, oh yeah, I have some AUC. AUC alone or whatever it is not a good number, right? It's one number and it's just, okay, fine, I can sort it. But then why and what happens if this doesn't hold? What happens if everybody gets, different, the distribution changes? How robust is my model? And we will do the best we can to make all the models we build tailored to be as robust as possible, for example. And you will have a knob that tells you the robustness, right? How much robustness price are you willing to pay? And then there will be simulations that show you what is the trade-off. So the next question is, what is my preferred stack? So I use PyCharm a lot for Python development. And we use, just Linux servers. I use VI plugins in PyCharm. And I have usually multiple servers with GPUs in them and some without GPUs and a lot of RAM. They all have NVMe solid state drives. They all have, either i9 chips or Xeon chips. And I would say a lot of memory is nice to have, but sometimes it's actually better to have not so much. So 64 gig is our low-end memory version, so to speak. To make everything work with less memory is also a good thing. You want to be efficient. And I would say get 2 GPUs at least in your dev boxes. That way you can parallelize a lot of the model building, not just TensorFlow and PyTorch models, also XGBoosts and so on, light GBMs. If you can train 2 models of these in parallel, then per time unit, you get roughly 5 to 10x the throughput than if you had 1 CPU only, right? So we benefit from GPUs and NVMe drives. These are solid state drives. They are 3 gigabytes a second, and they only cost you, a few $100. Definitely a good investment because you can read and write files super fast, especially since we're using data table, which is the fastest CSV reader and writer. You can write 50 gigs to a CSV in less than a minute, maybe even sometimes I think that was a minute to do the join and the write and the read actually from CSV back to CSV. So the whole thing was done in 1 minute for 50 gigs, and that's all because it's limited by the IO of the disk. So you want solid state drives. Okay, what is the next question? Oh yeah, perfect. So that's a good one. So there are sometimes problems where you have the same person show up multiple times. I remember the Allstate distracted driver challenge in Kaggle. They had a bunch of rows, but every row belonged to a person, but the person showed up several times in the same data set. So you would have one person being photographed holding their cell phone like this, and then maybe looking out the window, looking back in the car, looking down, holding the radio knob and so on. And you have to tell who is who, or what are they doing? Which of the 10 things are the drivers doing, the distracted drivers? Or maybe they were driving normally. And if you just fit a model on all these images, then of course it will remember that the person with the blue shirt is, the one that is maybe distracted or something. It's not actually learning that it's the arm that matters, but it's the shirt color that matters because you already saw that somewhere else and so on. So you don't want to, because they have the same event photographed multiple times, right? Like me holding my cell phone 5 different photos. And if I see 3 of them in training, I can remember, oh, if there's a white arm here, then it means he's holding the phone. But it shouldn't have been remembering my arm color. It should have been remembering the arm posture or something. So it's very important not to have the other 2 pictures to be in the validation set, but to be either all in training or all in validation. And for that, you would use the fold column. When you get these cardinality limits, that usually will tell you that there's either it's something that's approaching to be an ID column. That can happen if you have too many uniques, then it doesn't really tell you that much anymore because every row is different. So what's the point? Now, if it's a categorical, that could be a problem. Then it's just an ID. Then you would not want to, if it's a numeric column, like your number of molecules in your blood right now, everybody of us here will have a different number, right? And then it's okay to be different. So it's kind of tricky to handle all these cases, but we're trying to do our best job to detect the types and the data science types. So one type is the data type stored on the file. Another type is the type of the data, how it should be used when you're actually going into modeling. And certain cardinality thresholds can be used to decide whether or not a feature is numeric or categorical. Right? If it's too many uniques, then probably, and it's a number, then it shouldn't be treated as a categorical anymore, then it should be just a number, as I mentioned. So yeah, but I would say the fold column is something that's often overlooked. You can also make your own fold column. That is the column that tells you for this value, you're either left or right, training or validation, right? And if that fold column is, for example, the month of the year, then you can say, I want to train on January, February, March, and predict on April. But then it will also train on April, March, and January, and predict on February. And if you can do that well, maybe that is a good thing, depending on your data. That just means your model is more robust over time and doesn't really need to know everything about the past to predict the future. Maybe it's okay to do that sometimes, but you have to be an expert. So that's why the fold column is a user-defined choice. Which column should I use for that? Okay, let's go to the next question. This is about explainable AI and how we can avoid having problems with it and how do we empower it. So I would say that's a good point to go back to the slides. So the sneak preview into 1.9, which is what we're working on right now, the team has been relentless at building new products in the last few months, not just COVID modeling, as you might have seen in the news or in our blogs, but also in making multi-node work, collaboration between people work, model management, deployment, monitoring work. This is called model ops. Then MLI has gotten a full fresh face and also custom recipes. So I'll talk about that some more later. Then the leaderboard project that I mentioned earlier, with press of one button, you'll actually get a full leaderboard of relevant models. So in the future, in 1.9, if you have a data set, you can say start not just experiment, but start a leaderboard. And that will make you 10 or more models at once. And some models are simple models, some models are complicated, some have complicated features, some have easy features. And this trade-off between the feature engineering and the modeling, that goes right into this explainability, right? So I can make a one feature model that's very good, right? Because the feature is itself a deep learning model using BERT embeddings. And then you can say, oh, wow, I have a GLM model with one coefficient and I get the sentiment right every time. Well, yeah, because the model got the transformed data output, which is the feature engineering pipeline. It's not the model that mattered, it was the pipeline that mattered. And we are free to change the data along the way before it goes to GLM, right? That's called feature engineering. And one such feature could be the BERT embedding extractor. And once you do the BERT embedding extractor, suddenly your feature is much more useful than the raw text. And then suddenly a one coefficient GLM is amazing. So when you say you want an explainable model, does it mean you want a GLM, or does it mean you want no more than 10 kilobytes for your overall pipeline? Or does it mean you want to know what's in the pipeline? These are all good questions, right? And then another question could be, maybe you don't really have to explain the model, you just have to show that it's robust. Maybe in this day and age, it's futile to try to explain a BERT model to every last number, right? Because it contains hundreds of megabytes of state and you're never going to explain it. So might as well just look at how strong it is in terms of stability. So what happens if I do adversarial attacks and robustness testing and show you that my model is super stable? Will you be happy with that as an explainable, replacement, if you want? Is it just good enough to do model debugging and show you that it's super robust? No matter what you attack it with, it's always giving you the best answer. And maybe it does need this extra complexity to be that good, right? If you have a simple model, maybe it's not that good at being strong under adversarial impact. So if I attack you with like slightly modified data, maybe the simple model will falter, but maybe my super complicated black box model will not. Maybe you're actually better off getting that model instead of the simple one. So it's a very fast evolving space. The explainability is one aspect, but the definition of what is explainable is also not easy, right? Not everybody will say, oh, I just need, to understand what happens. Well, then you can study neural nets and then you know what happens. Is that enough? No, it has to be a little bit simpler. It has to be monotonic, maybe it has to be, it has to be explainable. Well, does it need to have one explanation or can it have a million different explanations for the same outcome? because often you have a lot of local minima that are all the same in terms of outcome, but they're all different. Each one is different. You can say, oh, this is what happened, and then the next guy will say, oh, this is what happened, and it's the same number that comes out, and neither one is right, because it's just one of many possible explanations for the same outcome. And then it becomes useless, right? So our goal is to find something that's unique and still simple. And if that's not possible, then it's probably better to be complex, but then actually robust. So there might be a phase shift, a transition to a show me that the model is stable versus show me that the model is simple. The next thing I would like to mention is the prediction intervals and in general residual analysis. And we'll have another slide later, but imagine you knew what the model did, right? Okay, fine, we have a model, it predicts. Now, imagine you knew where the model was weak. Every time you make a prediction for someone in Minnesota, it's bad, much bigger error, as measured in the holdout predictions. Well, then you can try to say, hey, I need better data for Minnesota, or look into what's going on, right? That's what I mentioned earlier. And maybe you can make a model that's better for those. Maybe you can use that as a metric to guide your optimization process. Do not have any subgroup that's worse than the other subgroup by this much. Make them all the same. And then your overall leaderboard that automatically gets filled could be scored by this robustness metric. And then you will have that as the guiding post for you, and not just the accuracy, for example. It will be accuracy divided by, you know, some other number that is based on the fairness or the stability. And that could be something very useful. And that's all doable today, because the scorers, as you can see in the very bottom, the metrics that compute the number, they're not just looking at actual and predicted, like, you know, cat, dog, mouse, and then the 3 probabilities, and then you say, what's my log loss? No, in the new version, you can actually pass the whole data set. So you can say, oh, I'm from Minnesota, and I have this and this condition, and hence I, you know, I'm gonna know exactly what I'm gonna do with my scorer to look at the fairness. I can look at the subpopulation and so on, and can weigh it differently. And I could, in theory, come up with a scorer that looks at the holistic view and makes it fair. So there's a lot of ideas, and we're adding these recipes in piece by piece, right? Other recipes that we added were the zero inflated models, where you have a lot of zeros for insurances. They don't pay you most of the time. Your claim amount is 0, but once you have a car accident, it's 6,000. So the distribution starts at 0. Most people have a peak there, like everybody has a 0, and then some people have some distribution here where they have their claim, right? Now the question is, how do you make a model that predicts all these zeros and then all these other bumps at the same time? And that is a custom recipe that does better than any other model before, because it builds 2 models in one. One is saying, classify me whether I am bigger than 0 or not. And once I'm bigger than 0, then how big is my loss? And so I can have 2 models, one classifier and one regressor, work together, and then they will make a better predictive model overall. And that's just one of many custom recipes that we are shipping out of the box now, and it's automatically detecting the case where it needs to be applied. Then the BERT models, the image model, as I mentioned, those are not very explainable, but they're really good, right? So maybe that's a not bad thing. And then we also worked on the epidemic models, and I'll show you that in a second. But yes, you can imagine there's a lot of effort going into this explainability, because everybody wants to know what's happening. At the same time, everybody wants the highest accuracy. So usually some of the people want both, and some want some only, but there's a trend towards give me the best and explain it. And that's of course not easy. And we have even more control over feature engineering. So how do you train models with in the absence of previous data? So if you don't have data, how do you train a model? Probably in the case of COVID right now, right? So what would you do if you had no COVID in the past? Well, you would look at other things. You would look at maybe uncorrelated data that's not the same old, same old. You would find maybe what are people saying in social media, what are people doing, how are they moving, you know, mobility maybe. Suddenly you want to know if a town is being inundated by people from New York that are running away from New York, going to Minnesota, let's say, suddenly there's all these people that now want their special shampoo that they always bought in New York, and you suddenly don't have it in Minnesota, and then every store runs out of that shampoo. If you knew that, you could probably deliver that same kind of supply to Minnesota and then sell more of your goods, right? So this whole supply chain optimization based on where people are moving, suddenly now you need to look at the data that says who's moving where in the past that was not relevant because you were in the same place all the time. So think outside the box basically and see which data sources can be used to augment your experiments. And then I know that you still have no labels, so yes, it's a problem, but at least you have, even in 2 weeks of data, let's say, you can still get some early signals, right? So you can see like, okay, we're sensing the demand. So we are building demand sensing models with our grandmasters to see from these early green shoots that you want, where people are saying, it's okay, we're getting out of this. Suddenly the demand will rise again. Can we smell that somehow? And you would not just look at the sales numbers over the last 12 months and 18 months and 24 months. Yes, that's right. You would have to look at new data, short-term data, social media, behavioral data. Maybe you need more of those, satellite imaging data where people are looking at which trucks are on the road where, how much oil do they have, who's driving where, which parking lots are full or not. All this kind of modern approach that the hedge funds are taking with data science, that is going to be more important. So you need to pay somebody to get that data and then to build models in the last 2 weeks and see if there's any signal. And how do you know there's a signal? Well, you need tools like Driverless to tell you which data sets are useful. So it's a good challenge, but it only shows that data scientists are more important than ever, right? You don't want to be just fitting some data set that you were given 6 months ago. This is much more interesting to actually deal with the reality of the world. So let me go back to what's new real quick to make sure that we cover that. So you can export models in 1.9. So you can export the model. Once you export it, it shows up in this other side here, the model ops. And then you have a model where it shows you when it was trained, and then where is it going to production. You can actually say here, deploy to production or to dev, and then you can look at the model as it scores, and you basically get an endpoint. You can query it. You can look at the distribution of incoming data, distribution of predictions going out, distribution of latency, distribution maybe of whatever you want. You can make your own custom recipes here. This is all Pythonic. So you'll be able to have alerts like if this and this happens, fall back to model number 2. If this and this happens, fall back to GLM. If this and this happens, call me no matter what time, and so on. All these things are what people are interested in. But another important aspect of this sharing here that I mentioned is that if you export it, someone else can import it, and you can tell who you want to be able to import it. So I can make a model for my entire group, and then everybody can get it. So we are no longer stuck on one instance, but we are able to share driverless models to everybody else in the organization if we choose so. So it's a more fine-grained control of who does what. And then the model of storage place here, where all the models are stored, that's kind of the central place where these models will sit. Then the MLI UI, as I mentioned, got improved, so you'll have more of these real-time pop-ups. So every time something is done, you can look at it. You don't have to wait until it's all done. You also can do custom recipes, so you can build your own MLI pieces where you can say, hey, I want to, for example, I want to build this and this Python recipe, run me these models, and then spit out these files. And then you can grab those files out of the GUI, basically. So we're still figuring out the best way for you to completely customize it all, but there is basically a precondition or postcondition. If you want, you give us something and we give you something, and that's the contract of that recipe. So you can, in the end, customize a lot of the stuff to your needs. And this is the automatic project that I mentioned. So when you push that create leaderboard button, you get all these models at once. And as you can see, 2 of them are completed, 2 or so are running right now, and the rest is in the queue. So there's going to be a queuing system, a scheduling system that will make sure that the machine isn't overloaded when we submit 12 jobs at once. And if you had a multi-node installation of driverless, then you will see more than 2 models running at the same time. You will run, like 8 at the same time on a 4-node system. So basically, you get more throughput, and you get control by not having them all run at once and run out of memory, as it is the case today. So today you would have to be more careful. Later you can just submit it and then come back when it's done. And this is the residual analysis I mentioned. So also in 1.9 you can have these prediction intervals enabled, and it will look at the distribution of the errors on a holdout predictions, and then based on those errors it will say, you're in Minnesota, error is pretty high, here is your error band, given the 90% confidence band, right? So there is kind of a heuristical way. It's not guaranteed, right? I can never say this will be what happens tomorrow, but I can only say, given what I saw in your model performance on your holdout data, these are the empirical prediction intervals. 90% of points had this error or less. So you can look at the residuals or the absolute residuals of your predictions, and you can say the quantiles of this error are so that this is where we end up in most cases, right? And if you say, I don't need 90%, I need like 60%, then you will get different bands. So you can control that. These are the BERT models. Also in 1.9 out of the box, you see the bottom left here, all the different types of BERT models. So not just BERT, but DistilBERT, XLNet, Roberta, Camembert, or Camembert, as we say in French, I guess, XLM, Roberta. All these different models are state-of-the-art models that are absolutely fantastic, and they really shine. As you could see earlier, I showed you these numbers here from the validation set. Also in the test set, they translate. So 40 log loss instead of 60 is a huge improvement, or 50 here. BERT is the best machine learning model for NLP and will be in there out of the box with Mojo support even, so you can productionize it. The same for computer vision. You can upload a zip file with a bunch of folders with images, JPEGs, PNGs, whatever. You just pull it in, it'll automatically make a data set out of it. It'll automatically assign labels to those folders and say, okay, these are all the mouse, these are all the cat, all the dog pictures, and then you'll have an image recognition problem out of the box solved with these pre-trained models that also have fine-tuning now. So you can load these state-of-the-art image models and have fine-tuning. And the thing I mentioned earlier was that there will even be a custom problem type. So not only will you do classification regression, but you can do segmentation or scene labeling or whatever you want to do. As long as you can define what the model does and what the score is, then you can do anything. So we'll not just have one column of predictions, but the column could be, a whole mask of segmentation shapes, like this. The human is here, the car is here, this, the house is here, the pedestrian bicycle is here, and all of that could be pixel-based maps that are part of the prediction of the model. And then your score is based on all of that and the reality, and then you get some smart overlap and so on. So it's more complicated models will work as well. So we're going to the Grandmaster style AI platform vision and not just classification regression. And it's a challenge to do it all in one platform, but I think if anybody can do it, then our custom recipe architecture should be able to do it. So that's our goal for this year. And this is another hierarchical feature engineering thing. Before I get back to questions, so we'll be able to control the levels of feature engineering as you want. You can say at the beginning, only do target encoding, and then do whatever else you want to do with feature engineering. So you can control the first layer. That could be a bunch of transformers, or it could be just one. You can say, I want to just do the dates transversion, transcoding, where the dates get mapped into day of the year, day of the week, and so on, and then treat those as regular numeric features or categorical features. Or you can do a embedding with BERT into a vector space, and then you run our feature engineering pipeline. Okay, this was the custom MLI. You've seen the same screen before, but yeah, you can do any explainers that you want with visualizations. And this was the epidemic model. That's the last slide. So we predicted reasonably well. Some of our teams were in the second or actually still are like in the first or second or third or fourth place in Kaggle on predicting the COVID spread and the peak and the how long it will take and so on, all using models. Some of them are driverless, some of them are outside, even simpler models, but this is in collaboration with actual hospitals. This is a SARE model where you model the evolution of the disease, how it spreads through different partial things that, like, people who are sick infect others who are not sick, right? People who are sick get better over time. People who are recovered, they don't affect anybody, and so on. So each of these equations down here reflects one of those realities, and then you integrate those equations up from the starting point where only a few people are sick. And if you tell us what the total population is, then we'll tell you how it evolves, roughly speaking. If you also tell us what the rate of exposure is, how quickly it spreads, and so on. So there is a bunch of features that you have to basically set for this model, or free parameters as we call it. And if you set those free parameters right, then the overall evolution will be very meaningful. If not, then it's junk. So this is a epidemiologist's dream, to set these parameters and then see what happens. And the model that we fit is getting this fit of this epidemic model, but then it subtracts that from the signal, and what's left is the residuals, and that's being fitted by the rest of the driverless pipeline. So you'll get both the XGBoost of the world that see the global behavior, and then you get the per country evolution of this epidemic, and together you get one combined model all out of the box. This is also in 1.9. So that's it. Now let's get back to questions before I point you to the docs. Yes, AutoML is not just parameter tuning or just feature selection, but it's actually helping with the validation scheme. That's a big one for me. It's, given this data set, how do I make a model that's good on tomorrow's data, right? Should I split randomly? Should I split by month? Should I split by city? Should I split by time? What should I do? If you don't do that right, then the rest almost doesn't matter. Because if you just randomly shuffle, and you know suddenly about these people that you shouldn't know, as in the example earlier, or you know about the future that you shouldn't know, and then you're asking yourself, did I do well in the past, and all these weird things, by random shuffling, you can hurt yourself, right? Doesn't matter how well you tune the model after you random shuffle the time series, it's just not gonna work. So what you have to do is you really have to understand your validation scheme, and only if that's done right, only then can you actually start digging deeper into the tuning. That's what the Kaggle Grandmasters do. They spend 1 month on the validation scheme and then the remaining month on the tuning. So AutoML should do that validation scheme step for you. And that's our biggest challenge right now. We have 14 Grandmasters, and some of them, I think, top 4 out of the top 6 in the world. And some of them are now thinking about how to automate these validation steps. Okay. What are the arguments, pro and cons, for driverless? Well, the pro definitely is, it can't hurt, right? Unless you don't have the money. Well, then you have to be an academic user, and it's still free. If you are a commercial user, you have a 21-day trial, and that's the current business model. And at that point, you have to decide whether you want to keep using it or not. But I would say I haven't seen a single person who has seen driverless who then said, yeah, I don't really need it. You always want to use something like that to have a baseline. Within seconds, it makes you the best baseline that you can come up with, given that data set. And I believe it's the best automatic machine learning platform out there today. And the only con is that maybe you don't learn as much about it if you let the machine do it. So you should still learn about data science, right? You should still look at the results of driverless and say, well, why did it do cluster and target encoding? What does it mean? What is XGBoost? What is LightGBM? What is TensorFlow? I'm not saying stop playing around with those tools, but don't waste your time writing your own for loops to tune something. That's definitely not a good time invested, unless you are just learning still. How long did it take to release driverless? Yeah, well, the first slide was run was done in like January or so, or December, around 2017, New Year's, let's say. The vision slide that Shri, our CEO, made, and all the pieces of that vision slide are now filled up. That started with custom recipes, bring your own, bring your own ideas. And I was like, whoa, that's difficult. And then he said, oh, do TensorFlow, do XGBoost, do open source, do everything. I was like, okay, that's also difficult, but let's see. And then try to connect it and have explainability in there and have accuracy in there and have these trade-offs, all these knobs, make it a GUI, make it also Python, productionize to Java, the whole pipeline. It's like, oh no, that's difficult, right? How do you do that? How do you write Python code, custom recipes, and then have a Python code automatically get translated to Java for production? How do you do that? It's not easy, right? Everything takes effort. And then how do you run this in a Kubernetes environment on the virtual clouds or private clouds or whatever? All of this has to work. So, and we got there. We're pretty proud of this. Unsupervised models, yes, we are working on those. So some of those are already unsupervised, as you saw in the visualization, but I would say that the real key is to say what's in my data. And there are supervised approaches and unsupervised approaches, and some of the unsupervised approaches that we are taking are in the pipeline of the model itself, right? So some of it, for example, could be that you have to do clustering to figure out what are the right distances between clusters, and that's a good feature. But we don't currently say, give us a data set and I'll tell you what are the 5 clusters. That recipe doesn't exist yet, but that could be one of the custom recipes in the future where you can bring any problem type. Yes, that is this one. So driverless is not currently doing a very good job at unsupervised, but we have ideas. Yes, we did the new parameters. So basically, you need to give us more data and let us tell you what is good about that new data. And there's no better tool than driverless to quickly churn through all the different possibilities of feature engineering and tell you which ones are good or not. And definitely will not replace data scientists. If anything, it will make it more productive you want to be in these days. And workflows, I'm not quite sure what you mean by when will workflows be supported. You can script everything in Python today, right? You can write a Jupyter notebook that uploads 12 data sets or make a custom recipe that does it, upload that one time, and then it does 12 splits and all that. So it's programmable. It's definitely not a problem. Also from R. And then we have an even bigger with the Mojo, the production pipeline. We cut off the models. We take the pipeline with the feature engineering and we stick it into the Spark environment. And in Spark, you will have scoring going on that on the terabyte data set, you convert the data with this feature engineering. And then the terabyte data will then suddenly be trained on a sparkling water cluster on a GVM model or something, right? So you can combine the power of driverless with a terabyte sparkling water installation in Spark. So everything will be scalable and big data. So you can do anything in that land.
Arno, I think we have time for one more question.
Yes. Yes, you can export MLI graphs as images. That's right. You do have that. And I think we're working more and more on that. So all of our pictures right now you can download, but I agree it's not yet perfect. So we're working on more of this adding benefit to you. And also we have more insight tabs that show up with insights. And some of those are Vega Lite plots. So these are very portable plots that you can port in Word, port in any language, any other visualization platform. So we're trying our best to make it consumable by you. So thank you very much for your attention today, and I hope you can benefit from driverless AI in this day and age. And thanks for your attention. Take care. Bye-bye.
Yes, thank you, everybody. Just want to remind you that we will provide you with the link of the recording in about a day or so. So we want to wish everybody a great rest of your day, and thank you, Arno, for the great AMA session.
Thanks. Bye-bye.
Bye.